Hello everyone. Sorry I couldn't be there with you today, but today we're just kind of talking about some classifications of rigid motions. No new material, just thinking about how we can combine things together so that we can classify. Okay, so up here at the top you've got kind of a little starter problem to think about. Two students are trying to determine whether a composition of rigid motions is commutative. Commutative means can be done in any order. Paula translates a triangle and then reflects it across a line. Then when she reflects and then translates, she gets the same image. She concludes that compositions of rigid motion are commutative. Keenan rotates a triangle, then reflects it. So that's what he's doing down here. When he changes the order of the rigid motions, he gets a different image. He concludes that compositions of rigid motions are not commutative. So is the issue in part A that Paula didn't use grid paper? No, with graph paper, she would have had exactly the same result. She just happened to pick an example where the order was not significantly important to doing the problem. So what we would say is that Keenan gives a really good counter example that compositions are not always commutative. So for part A, it's that Paula happened to pick an example that worked, and then Keenan says, whoa, wait a minute, and he tries something different. Because if you look at his, he does a rotation and then he reflects. So there's the rotation right there. And then he reflects it and he ends up over here. This one is do the reflection first. So go that way, reflect, and then rotate. So you get a different answer. So basically what you want to take away from these two examples is sometimes compositions are in fact commutative, other times they're not. So since they're not always commutative, we want to make sure that we read the directions about what the problem's telling us to do. So let's go down to the theorem that is down here. No, we're not doing two-column proofs with this. This is just for your information so you can use this. The composition of two or more rigid motions is a rigid motion. That just means that if you do a couple of rigid motions or more, that the size and shape will be preserved. What it doesn't tell you is that the orientation will be preserved. So if you look at the original orientation, the Q and the R are on the bottom, but once we've done a couple of transformations, the Q and R aren't on the bottom, but you can easily see that this is the same size and shape as the original. That's all it's telling us. All right, let's flip to the back side. Oh, by the way, if I didn't tell you, these notes are pretty short today, so you shouldn't have any trouble finishing the Savas assignment. Okay, so first thing it says is defining a glide reflection. So a glide reflection is a combination of a reflection and a translation, or a translation followed by a reflection. So it's that combination of two ideas. So if you have two reflections, that's not a glide reflection. If you have two translations, that's not a glide reflection. It has to be that combo. So first thing it says is there, by the way, we're using these to help us answer our questions. Is there a rigid motion that maps ABC to A prime, B prime, C prime? So this answer is going to vary for each of you. So what I want you to do is I want you to pause the video right here and come up with what you think is the correct answer on this. Okay, so the answer is there actually does exist a rigid motion that's going to take this from here over to here. And some of you are sitting there right now saying, oh yeah, absolutely. I could reflect it and then I could translate it down. Some of you are thinking about doing the translation first and then reflecting. Both of those are great glide reflections. So the answer is absolutely yes. And then you're going to write right after that what you thought was the best choice. I'm just going to put 3 little dots there. If you need to pause it, you absolutely can. So yes, there is a ridge of motion that maps. And part of the reason that I know that there is because the size and shape have been preserved. So by that, all the angles and the side lengths have been preserved. All right, next it says, does a reflection, translation, or rotation map ABC to A prime, B prime, C prime? So since the orientation, in other words, which letters are on top, which letters are on the bottom, how they relate to each other, is not preserved. So you notice how the A and the C get swapped. Down here it's A on the left, C on the right, and then here these get done. I know that there has to be a reflection. And I'm going to say at least one. I know some of us have already thought of the answer, but we're going to write down at least one reflection. Okay, so now this one is definitely going to vary. So what composition of transformations maps A, B, C onto A prime, B prime, C prime? Okay, so this is one option. If you want to pause it right here and write down your choices, that's fine, because notice we don't have a lot of notes left. So, you know what? It's going to take you 30 seconds to write something down. So if I were in class with you, I would pause here and have you come up with some ideas. Here is one and only one option. So here's an option for you. You could reflect across, let me get you to write that down, reflect across x equals -1, then translate down 5. So let's think about that for a moment. So here's the line x equals -1. It's right there. If we reflect across it, we would end up with this triangle. And then I could just slide that triangle down spaces so it would fit into directly on top of that. Here's another one. You could slide the triangle down, then reflect across x equals -1. Now the way that I have written this out, this is what it looks like. So I would do the reflection first. So I'm going to put a little open dot there, meaning I'm doing a composition. So our x equals -1. And then I would translate second. So you'll notice it's to the left. So it's 0, -5. And then I'm going to write my letters for triangle A, B, C. So if I do this order, I do the reflection first, then I do the translation. So hopefully that went really well and you have some ideas. If you decided to swap these, of course you can do that. Remember on these we work from our right side to our left side, so it's kind of counterintuitive. All right, here's our other example for today before you go in to do your notes. And this one is determine which glide reflection. So when they say glide reflection, that means you're going to do at least one reflection and at least one translation, will result in JKL mapping to J double prime, L double prime, K double prime. So you definitely have some choices on this one. I'm going to ask you, if you want to pause right here, and then when you are ready, turn it back on once you've given a try and see if it works. If you're really stuck, it may help you to find the translation first and then the reflection. I did the reflection first and then the translation, but it's totally up to you. Okay, so I'm going to assume at this point that you have tried it out. So if you wanted to follow the books tip, which is do the translation first, I would move my letters over to here. So my L prime would be there, my J prime would be here, and my K prime would be just over here. And as you can see, that translation is going to be 1, 2, 3, 4, 5 spaces to the right. So that would be capital T, 5 spaces to the right. Okay? And then you would reflect, and if you look at the reflection, the point that is halfway between these 2 points, where it's going to end up at, is going to be the line that is going straight across here. And that is a y equals +1. So reflection, y equals 1. And I'm going to put parentheses around that, and then I'm going to write the letters for my original triangle of J, K, L. Now, when I did it, I did just the reverse. So that's one option. Here was another one. And this is the one that came to me first. I did the reflection first. And then I slid the figure to the right. I know, not that original. As long as your glide reflection, because remember, it does have to be a glide reflection in this case, just because it has to be the glide reflection, because it's saying that you do need to use a translation and a reflection. Now, let's down here, let's finish up our notes. Here are the ones that we have talked about so far. You guys just did a quiz over reflections. So that would be your original triangle up here, reflected over to this one. These images are pulled straight from your notes. The second one is a translation. So that would be the figure in black, translated over to the left and down. And then there is a rotation. And again, you can do as many degrees as you would like, but we will limit ourselves on tests and quizzes to 90, 180, and 270. Can you do other measurements? Of course you can. And then today is the glide reflection, and that's the one where you glide it somewhere and reflect it, or as in this case, reflect then glide. It does not matter which one you do first. Okay, so that's all of today's notes. At this point, you should go out to Savas. Sorry, I flipped over to the blank side. I forgot mine was printed blank. You should go out to Savas and do the 3-4 assignment in Savas. That's the one you should do. And that's it. If you have questions, I want to see tomorrow when I come into class and I say, what are your questions? You can ask me questions about the notes. Take screenshots of questions that you don't know how to answer on Savas, and I will help you out and get you straightened out on any of those problems that you're having difficulty with. This is also a great opportunity to catch up on any assignments you might be missing. So you might want to go back through and look at your like what you've done so far and see if you have done 3-1, 3-2, 3-3, the Delta Math assignment. Make sure that those grades are in Canvas and in Infinite Campus. And if there's an issue, great time to review those grades and get everything all caught up. I hope that all of you have a wonderful day, and I will see you back on Wednesday.